My name is Aishwarya Kara, and I will be explaining Kirchhoff's current law. Kirchhoff's current law, or KCL, is an essential tool for circuit analysis. It states that the total current that enters a node or junction in a circuit must be equal to the total current that leaves the node or junction, which is kind of similar to the law of conservation of mass or energy. We're going to verify this in the following example. Here I have a simple series circuit with a voltage source and 3 resistors. Because this is a series circuit, there's only one path for the current to flow, so the same current flows through every component. The voltage, however, may differ since it's divided amongst the components depending on their resistances. If this were a parallel circuit, there are multiple paths for current to flow. Therefore, the voltage across each branch would be the same because they're all connected to the same 2 nodes, and the current splits amongst the branches depending on their resistance. To analyze current direction, I drew a clockwise loop where the current leaves the positive terminal of the source, goes up the left wire, through the resistors, and returns to the source at the negative terminal. Now, let's apply KCL at each node. At node A, current enters from the source on the left, and the same current I1 leaves toward the resistor R1. So the equation is I source minus I1 equals 0. At node B, I1 enters from the left, and the same current I2 leaves downward through R2. The equation is I1 minus I2 equals 0. At node C, I2 enters from above, and the same current I3 leaves to the left through R3. And the equation is I2 minus I3 equals 0. And finally, at node D, I3 enters from the right, the same current IS, or I source, leaves going up into the negative terminal of the source and is therefore I3 minus I source equals 0. Now overall, when you combine these equations, you get I source equals I1, which is equal to I2, which equals I3, and is exactly what we expect in a series circuit. The same current flows through every component, and KCL verifies this at every node. Thank you for listening.
Everyone, my name is Yoshio Seifi, and I will be explaining Kirchhoff's other law, which is Kirchhoff's voltage law. These laws are super important for understanding electric circuits. I'll first explain what the laws say and where they come from, and then I'll show a quick example problem to apply the law. These laws help us analyze circuits that are too complicated to solve with just Ohm's law. Kirchhoff's laws are basically 2 rules that come from physics: Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's voltage law states if you go all the way around any closed loop in a circuit, the sum of all the voltage changes is 0. So, key notes to take in here when you are solving circuit problems is when you go from the negative to the positive terminal of a battery, that's positive voltage. So as you can see in this left node over here. And when you go with the current through a resistor, that's a voltage drop. So you'll have negative current times resistance. So now that we have taken this into account, let's solve a practice problem. So over here, we have a circuit with 3 resistors, 1 battery right over here. One second, we have a battery right over here. And we have R1 right here, R2 right here, and R3 right here. And as you can see, it's going from the current will take clockwise. We'll go around the circuit clockwise. And since we're going, like we said earlier, we're going from negative to positive, so that's positive 45 voltage. And then each resistor is going from positive to negative, which will be negative IR. And so this problem, we will ask what the current is in the circuit. So to solve this, we're going to need to use our Ohm's law that we also know, I equals V over R, and Kirchhoff's voltage law, which is delta V in any loop, sum of delta V should equal 0. So let's analyze the circuit and create an equation. So like we said, we're going to take it clockwise. So the battery over here is going from negative to positive. So let's first start at the battery. So that's positive 45. And R1. R1's voltage, or for any voltage right here, using Ohm's law, voltage equals I times R. So we'll have, this is going to be negative IR though, however, because we said there's a voltage drop. So we're going to go minus I times R1, and then let's go minus I times R2 minus 7.5, oopsie, sorry guys, I times R3 should equal 0. And keep in mind, since this is just one circuit, current is equal everywhere. Sorry guys. So it's the same, current is flowing the same everywhere. So that's why we only have one current, since it is just one circuit. So from here, it's pretty easy now because we have the values of R1 and K in thousands, and we have R2 and R3. So we have 45 minus I times R1, which is 5K. We'll keep everything in K right now. Actually, let's just do K. And then we have minus I times 10K. Sorry guys, I'm running out of room. Minus 1 second, guys. Minus I times 7,500K, which is 7.5. Yep. Okay. So from here, equals 0. So from here, we just have to solve a simple equation. So we have all of these together will be 45 minus, if we add all of these together, I times 15,000, and then sorry guys, I'm just calculating, 15,000 plus 7,500, which this is going to be 2, perfect, should equal 0. And so 45 equals 22,500 I. Now you're just going to want to divide now by 22,500 equals the current. So now let's just do that. And so we get I equals 0.002 amps. Just like that. So now guys, what we have solved is a simple circuit that is just asking us what the current is using KVL and Ohm's law. Thank you for watching.